Here at TRI, we believe robots should amplify people, at home and at work. To achieve this, we conduct cutting-edge research to make robots more flexible, robust, and general purpose. We've had a bit of a breakthrough. Today, TRI is announcing a new method to teach robots dexterous skills quickly and easily. Our approach is built on a powerful generative AI technique called diffusion policy. This allows us to teach robots much faster and with significantly fewer demonstrations. The approach holds great promise for creating what we call large behavior models. Just like large language models have revolutionized chatbots, these behavior models will allow robots to perform useful work in ways never possible before.
Up until now, the majority of robotic manipulation work has focused on pick-and-place style tasks, where a robot is limited to relatively simple sets of objects it's rearranging. Our new approach goes significantly beyond that and lets us explore much closer to the limits of the hardware. TRI's robots are now capable of using tools, pouring liquids, and peeling vegetables. It's exciting to see them engaging with their environments in rich, multifaceted ways, and all achieved without changing any code or explicitly programming any new skills. Using this technique, we've taught over 60 diverse behaviors to our fleet of robots. The process starts with a teacher, demonstrating a small set of skills through teleoperation. Then, our AI-based diffusion policy learns in the background over a matter of hours. It's common for us to teach a robot in the afternoon, let it learn overnight, and then come in the next morning to a working new behavior. To make this level of dexterity possible, every part of the robot platform must be solid, from the hardware all the way up through the entire software stack. One key enabler is providing human teachers with a sense of touch or a haptic teleop device. Also, just like people, we found that robots learn better when they have a sense of touch. And a perfect example of this is the task of flipping a pancake, where the robot has to make contact with a surface it can't see. Without a sense of touch, it struggles and performs poorly, but is successful in learning the skill once it's able to feel its interaction with the environment.
This is only the beginning. Our team is deeply focused on achieving large behavior models that I mentioned earlier. We anticipate the next breakthrough will be when we've trained the robots with enough dexterous skills that they're able to generalize, performing a new skill that they've never been taught. To realize this, we're building a diverse curriculum for robot learning, essentially a kindergarten for robots, to teach them numerous foundational skills that are useful for working alongside people. We're on pace to teach hundreds of new behaviors by the end of the year and over 1,000 by the end of 2024. We're also leveraging our expertise in simulation to augment our real-world teaching. And finally, we're developing fundamental tools for fleet learning so that when one robot learns, they all learn. I've been working in robotics research for a long time now. The tasks that I'm watching these robots perform are simply amazing. Even a year ago, I would not have predicted we were this close to this level of dexterity. And the rate at which we're able to teach new skills is simply astounding. Nearly every day, I wake up to a new message showing the robot doing something it couldn't do the day before. This is an incredible time to be a roboticist.